important and
Q and D is $3.70. You have 5 more quarters and dimes. And that's about it. Oh, determine how many dimes and quarters you have.
restart.
What? Bruh. So you get the $3.75.
Okay.
You have 5 more quarters than dimes. And you have to determine how many dimes and quarters you have.
Okay. Anyone want to take a guess as to what one of the equations might be?
I got Q plus D equals $3.70.
No.
Wow.
Hey, you tried.
You know what? At least I gave an effort. I'll say it, but I do it.
That's also not right. So Annika guessed 5Q plus D equals 370, and that's not correct either.
I think I have one.
Okay, go ahead.
Well, can I write it on the board because I can't really write it?
Just say it.
Okay, so since it's 5 more quarters than dimes, the dimes would be D plus and then in parentheses Q plus 5 and then the end
It's
of
not that complicated.
It makes sense.
It is D plus something.
5Q?
Not 5Q.
5?
Just 5.
Just 5.
Equals Q.
Equals Q.
But wait, isn't it 5 more than?
5 more quarters than dimes. So however many dimes we have, if we added 5 to it, we would know the number of quarters. You need one more though. Chris, did you have one? Somehow we need to put the 370 in there. Go ahead, Andre.
Is it 10D plus 25Q plus 370?
You're missing something. It's not 10, but it's 0.10. Because remember, these are cents.
I put D7 instead of $3.
Okay. So that would be okay. If you move the decimal for everything, that would be fine. So remember, anytime you're given something with coins, you need to remember that you know what dimes and quarters or whatever it's asking is worth. So you need to incorporate that every single time. What's our next step? Plug what in and where?
Plugging D plus 5 for Q.
Yes, into this cube. So 0.1, I don't really need that 0. D plus 0.25 times D plus 5 equals 3.7. And then what? Distribute. Zero 0.25 D. What is 5 times 0.25? It is 1.25. Okay, when we combine our D's, how many do we have? 0.35. And then when we subtract 1.25 from 3.7, what is that? 2.45. So when we divide by 35 cents, what is D? 7. So if D is 7, what's Q? Say it again. 12. And then we could put both of these in just to check it. D times 0.10 is 0.7. 12 times 0.25, what's that? 3. Does that equal 370?
Yeah.
Yes. So that works. Yes. So remember that you need to look at your word problem and see if it's money, you need to set it up with your money's worth. If it says something costs this much or it's worth this much or whatever it is, it's talking about that variable and you don't have to solve for that variable. Just pay attention to how you need to solve those. Okay? I'm gonna pass these notes out, but we're not gonna start them until after lunch. We're doing elimination today. That means after today you'll know all 3 ways to solve a system. I've changed your test dates. So we're gonna do elimination today. You'll get practice and time to practice. And then when's the next time we see you? Wednesday? We're going to review for the test, which means Friday is our test. We're going to fill in, and these boxes are, 1, I want you to write this here. I'm going to say it first and then I'll write it. Add or subtract, add/subtract, or multiply a common factor.
What is that word after 4?
Multiply. Add or subtract or multiply a common factor and add or subtract to eliminate a variable. Because that's basically what we're doing. Because the steps are a little weird. I'm still going to fill this in. So add, subtract, or multiply the equations to eliminate the variable. But if we're multiplying by like a common factor or a common multiple. Some of them will have common coefficients, the variables, and we'll be looking at those to see if we could add or subtract them. If they don't, then we end up multiplying. We solve for whatever's left, put that back into the original, just like with substitution, for that last piece to find whichever variable we didn't find. So this kind of goes along with this. If there aren't common coefficients, multiply by one or both by a number or a multiple to make them common. So in words, that doesn't make a whole lot of sense, but let's do some. Does anyone still need this? We're going to do the following problems together. So if you want to circle these. 1, 2, 5, 7 through 10, and 15. 1, 2, 5, 7, 7 through 10, and 15.
That's literally no.
We're trying to eliminate a variable. So think about what that means in anything else. When you eliminate something, what happens to it?
It goes away.
It goes away. So same thing. We are trying to eliminate a variable. First, let's look and see, do we have a variable with the same coefficient, the number in front? Do we? Yes. What would that be?
1.
1 is the coefficient. What is a variable?
Y.
Y. So we can say that both of these have the same coefficient. We can eliminate these by subtracting the two equations. So I'm going to subtract this entire equation. Y minus y is what? 0. 3x minus x. 2x. 4 minus a negative 2.
Plus, it makes sense.
It makes sense. We eliminated our y variable, and now we can solve for x. So I'm going to subtract 6 to the other side and divide by 2. Or minus negative 2. You're subtracting the entire function.
And then 3 minus.
And we have to find out why too.
Yes. So now you can put negative 3 into either of these and find y. I'm going to do this one. What is the value of y?
Negative 5.
Negative 5. Remember, these need to be ordered pairs. You put negative 3 back into this equation. Negative 3 minus 2 is negative 5. Other questions on that one? Yes.
On this test, we'll be able to use one calculator.
Yes, so you'll have an option. So there'll be 2 objectives. One will be your word problems, which you will still have whatever choices you want. And then one will be just solving equations, and you can use whatever methods you want.
That's what we're.
Yes.
So do we have to do the substitution method, or can we use Desmos?
You could use Desmos, but if you're using Desmos, you still have to graph.
Yeah.
Yes. So I'm using this equation, and I put negative 3 in. Right. For number 2, do we have a variable that has the same coefficient in both?
Yeah.
What is it?
X.
So in this case, just x. X has the same coefficient. So just like I did here, these both have coefficient of 1. I can subtract this second equation, but I'm subtracting the entire equation. X minus x is 0. 4y minus negative y plus positive 5y. 13 minus 3 is then 10. Really, I don't need that 0. What is y?
2.
Now I can put this back into either one and find x. I'm going to put it in this one. So I would need to add 2 to solve for x. So in this case, x equals 5. So our solution is 5, 2. Even though we found y first, it's still xy, so don't confuse those. No. That's why we're going to do different problems, because it's going to look a little different for some of these. Some of these, if you see that these both have positive 1, yes, subtract. But if they both have like negative 1, then you have to add one of them, and it becomes a little different. Like 5. So in this case, do we have a variable with the same coefficient? You don't?
Yes.
The y's both have the same coefficient. One is negative though. That's okay. So with that one, I just want to make sure I have it. Because you have one negative and one positive, you could add them together, and those would still cancel. 3 plus a negative, or you could say the opposite. So we've been subtracting the bottom one, but you could have done it the other way also. Take the bottom one, subtract it from the first one. Take the top one, subtract it from the bottom one. If I were to subtract this, 3 minus negative 3, would they cancel? No. So I'm just going to add these two equations together. So no, you're not always subtracting. And sometimes you have to think about which one would be better. If I do this, will they cancel? Alright, so if
why
I
is it adding? Wait, why is it adding again?
if we subtracted, these y's would not cancel. Because it'd be 3 minus a negative. So you'd be adding. So we are adding here negative x plus 2x, 1x, 3y plus a negative, 3y, 0. Sorry, I messed this up. We are still going to do that, but I forgot that these are set up a little differently, so we have to solve one first. I need to move this first. My bad. So with these equations, if they're not x plus y or whatever equals a number in both, you need to fix them. So this one, I should have did that first. This one, the equals is not in the same place, and it needs to be, or this doesn't work the same way. So because this y is on this side and this one, I'm going to do the same thing and subtract. I'm just rewriting. So we move 3y to the other side so that they look the same, they have the same format. Yes.
What is it?
Minus 3y. I just wrote that.
Why is it
Do these two look identical, the format? No. So we need to get them in the same format. The only way to do that is to move this to the other side. By subtracting. Okay. So now when we solve this, it's going to be different than how we started. If I added these two together, negative 3 plus a negative, or just negative 3 minus 3, would they cancel?
Yes.
Negative 3 plus negative 3, or negative 3 minus 3 would be negative 6. So I can't add the two together. So I would need to subtract in this case. So I said adding before, but that's because I didn't set it up right. Two x minus a negative x is what? It is going to be positive 3x negative 3y minus a negative 3y. 0. 10 minus 11.
-1.
Negative 1. It's best when you do these to do them step by step. Go slow at first until you get the hang of it. Now I don't really need this 0. And this one you do end up with fractions. That's okay. So your x for this one is negative 1/3. And we need to figure out what y is. You can either put this back into the original, back into the other equation, or back into the one we moved. It does not matter. You should get the same thing either way. I think I put it into this one. Which one do we want to put it into? It doesn't matter. Which one? Okay. So if we're putting this back in here, negative 1/3 equals 3y plus 11. This becomes positive 1/3. I'm going to write this as a mixed fraction, but find out what it would be as an improper fraction if we subtract.
Would it still be correct if we wrote it in an improper fraction?
Either one would be fine. Since it's an ordered pair, it's not like slope that has to be improper. It doesn't matter. 1/3 minus 11. What is that as an improper fraction?
-11 and 1/3. Oh wait, hold up. -11 2/3. No, -10
Negative
2/3.
10 and 2/3. That would be the mix. What's the improper?
Nothing.
So in your calculator, do 1/3 minus 11.
It's 32/3.
Negative.
Negative.
So this one's going to have really weird fractions. That's why I want to do this one. We're going to divide both sides by 3. But when we do that, your calculator is really just multiplying this by 1/3. Yes. Yes. You can sit right there and I'll grab you. In your calculator, just do negative 32/3 divided by 3. But make sure it's in fraction, a fraction form. What did we get for that?
Negative 32/9.
Over 9. So you have these really weird fractions as your ordered pair, negative 1/3 and negative 32/9. That is the answer. It just worked out really weird. Okay. Do we have questions so far before we move on? For 7, do we have a variable with the same number coefficient? Yes. Which one? Is that the only one? So in this case, we really have 2. So to get rid of my x's, I would subtract. to get rid of my y's, I would also subtract. So when we do this, 3x minus 3x, we get 0. Negative 4y minus negative 4y is what? It's still 0. Negative 10 minus negative 13. Negative 10 minus negative 13. So you're adding 13. So it's just 13. What does this mean?
It means 0 equals 3.
What does that mean?
It means there's no answer.
Not necessarily. Neither of those answers is correct. It's no solution. Does 0 ever equal 3?
No.
No. Okay. So if you start to see that when you're going to solve them that they're both going to cancel, but then it doesn't equal the number on the other side, you get no solution. For 8, we have the same coefficient kind of in both. Would I need to add or subtract these to get rid of them, to eliminate them? Add. If I add these two, what happens? We get 0, y plus a negative is 0, negative 10 plus 10 is 0. What does this mean? Infinitely many solutions. But that's not just with zeros. Most of the time that's what will happen. You'll get 0 equals 0. But you may get a number equals a number. As long as you get that, it's infinitely many.
On coding academy, it doesn't really have those type of problems with infinitely many solutions. What would be the way to tell if it's infinitely many solutions?
If you solve them and you get 0 equals 0. Or like a number equals the same number. In 9, do we have the same coefficient in either one? No. Can still be solved though. Pretend that we wanted them to be the same. So it doesn't matter if you're looking at the y's or the x's. Let's say I wanted these to be the same. How could I make this x be the same? What would I do to it to make it a 2? Or what could I do to it to make it a 2?
Add 2.
So remember that's 1. So if you add 2, you're going to get 3. You can multiply by 2. But what you do to one thing, you have to do to all. So you're really multiplying this entire function by 2. But not just 2, because then they wouldn't cancel. You need to multiply them by negative 2. I'm going to rewrite this one down here. So negative 2x minus 6y minus equals negative 12. Now do we have a variable with the same coefficients or the same number? Yes. So how would we get rid of this? Would we add or subtract? Add. So when we add our x's, we get 0. When we add our y's, negative 7 plus negative 6, which is the same as negative 7 minus 6, negative 13. Negative 1 plus negative 12, or negative 1 minus 12, negative -13. Don't really need the 0. What is y? 1. So now this is kind of going back to what we were doing before. We just added an extra step in. Right. Doesn't matter which one we put this in. Which one do we want to put it in?
Second
The second one? Okay. So 2x minus 7 times 1 equals -1. This becomes -7. And then we have to solve for x. So 2x minus 7 equals -1. Add 7 to both sides. And then we get a 6. And x equals 3. So 3, 1 is our solution there. Okay. 4, 10. Do we have any coefficients with the same variable? No. And in this case, we don't have something with just a 1 in front. So we're going to have to do something to both of these, really. We can either make the x's the same or the y's the same. Which one do we want?
X.
The x's. So we need to think of a number that we can multiply these x's by and these x's by, and they get the same thing. So think of multiples of 3 and 5.
5.
I think those
5 on the top and 3 on the bottom. Now, we could make them both positive and then we subtract, or we can make one of them negative. It doesn't matter. I wrote that backwards. So anytime you have this type of problem, you've now added 2 extra steps. Because you have to distribute that before you solve. So the first one becomes 15x plus 15y equals 45. The second one is 15x plus 12y, hold on 1 second, equals 30. You just read that. Okay. Now do we have a variable with the same coefficient? Yes. We didn't multiply by a negative, that means we're going to have to subtract. Again, you could subtract the first one from the bottom. I'm just not doing it that way. Our x's are going to be eliminated. 15 minus 12y is 3y. 45 minus 30, 15. So we still end up doing the same thing. We just added in 2 extra steps before we ever got there. So in this case, y equals 5. When you added in both of those extra steps and then you solve for a number, you can either put this into one of the 2 originals or put this in one of the 2 new ones. It does not matter. You should get the same thing either way. I'm just going to pick the first one. Right, so 3x plus 3 times 5 equals 9, and we need to solve for x. When we subtract 15, we get what? What number did you say? I think it's a little higher. Higher in the negative direction, a little lower, I guess. Not 4, not -4, but -6. So x is -2. So 2,5, -2,5 would be our solution. Okay. One more. I want you guys to walk me through this. How would we start this? Multiply the x's by what?
The top one by 5 and the bottom one by -4.
Okay, that is one way you could have done it. Is that similar or different than what you're going to say? Remember, you don't have to solve for the x's. You could solve for the y's first. It does not matter. Whichever one you want to do. I wrote those parentheses wrong. But that does mean you need to distribute to both. 20x minus 10y equals 25. Negative 20x plus 12y equals -4. Okay. And then what? If we subtracted this entire function, 20 minus -20, would that cancel? So we add, this would become 0. This would become positive 2y. 25 minus 4 would give us 21. So y is going to be a fraction.
In order to make it into a decimal.
You could do that too. It's 10.5.
10.5.
So if you wanted to, yes, you could do that. And then we need to put that back into one of them. Which one do we want to put that back into? The one on top, the first one, okay. 4x minus 2 times either one of those. I'm just going to put 10.5. What is negative 2 times 10.5? Negative 21. Add 21 to both sides. We get 26. So we still end up with a fraction or a decimal. So I'm simplifying this. 13 over 2, or what is that as a decimal? 6.5. So you can either have your ordered pair in fractions or in decimals. Don't mix and match. Either stay with fractions or stay with decimals. Do we have any questions on this? For the rest of class, I want you to finish those examples. If we all finish those examples and we have a little bit of time, we can play bingo with math, so it's not that fun. But it's solving equations bingo, but that depends on how much you get done and how fast you get it done.
Which the prize?